Okay, today I use pink, yellow, and a little bit of blue. So grab those crayons or highlighters. We're going to write notes titled Divide Whole Numbers by Unit Fractions. Please title your paper Divide Whole Numbers by Unit Fractions. Now let's remind ourselves what unit fractions are. Ooh, that's a little messy. First, let me fix that. Divide whole numbers by unit fractions. I do not have the best handwriting, but I try. Remember that you can pause at any time. So, unit fractions. I'm going to write 1/3. Now, for a unit fraction, the numerator is always 1. The numerator is 1. And the denominator can be any number. A unit fraction always has a numerator of 1 and any denominator. So we have that at the top of our notes to remind ourselves, and we can talk about dividing whole numbers by unit fractions. So I want you to think, how many of the fraction fit inside the whole number? How many of the fractions fit inside the whole number? And we're going to use two different models before we look at the standard algorithm. How many fractions fit inside the whole number? We're going to look at the problem 4 divided by 1/3. 4 divided by 1/3. Four divided by 1/3. And we're not sure what that equals. So let's look at a model using rectangles. I'm going to draw 4 rectangles because I'm starting with the number 4. 4 is our whole number. Oh, I think that's a little bit long. I'm not going to fit 4 across the page. Let's go ahead and erase those and try again. It's really important that we try and keep our rectangles the same size. So 4 rectangles across the page. And I'm dividing by 1/3. So I'm going to split or divide each of these rectangles into thirds. And then see how many there are. How many 1/3s fit inside 4? 1, 2, 3, 4, 5, 6. And I'm sure you can see at this point that there are 12 thirds inside 4. Now let's use a number line as well. I'm going to draw a number line across, and we'll start at 0 and we'll go to 5. I'm going to divide my number line into 5. Even though I start with 4, I usually like to go one whole number past what I'm working with. So we're going to divide all of these into thirds, which means we're dividing by 3. We'll start at 4, and we're going to see how many times it takes me when I'm traveling by thirds to get to 0. That's a bit thick. Let's shrink that down a little bit. Okay, we're starting at 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That took 12 hops. 12 jumps. Just like in my model, there are 12 1/3s inside 4. So let's go ahead and look at the standard algorithm. For the standard algorithm, we have a little memory trick, and I will explain in just a second. But off to the side, I would like you to write the words keep, change, flip. Keep, change, flip. So we're going to write our equation out, or our problem out, 4 divided by 1/3. Now I want us to remember that division and multiplication are inverse operations. So highlight keep in pink, and then also the number 4. We're going to keep our first number. We're going to change the division symbol, and then we're going to flip our fraction. Keep, change, flip. So if you noticed when we used our model, we counted how many times 1/3 would fit inside. Now, we've kept the 4, we've changed division into multiplication, and we've flipped our fraction over, and then multiplied using the standard algorithm. The reason that this works is because when we're looking to see how many times 1/3 fits inside our whole number, we can multiply by the denominator of that number. We'll look at lots of example problems later, so you'll see why it works. Thanks for watching.